So the purpose of my presentation today is not really into diving into the robotics technology. So I'll be talking more from the industry insight point of view, how robotics has been doing and what's the trend in the industry, and what is the major motivator for robotics to place its foot more strongly. So what is the motivation for all of us to go into the research and development from robotics point of view? So I think robotics have evolved dramatically and I think gradually also from the last 20, 30 years. And I think today we are talking about artificial intelligence, machine learning, and integrating all these concepts into robotics. So robotics now is a very complete and big word. And I think so today I'll not take more than 1 hour of yours, and I'll be presenting around 32 slides. And so the focus would be more on the usage of robotics in the industry, in the manufacturing industry. Give me a second. Let me put my presentation in the presentation mode. Yeah. All right. So you were saying something. I heard you say something.
No, it was a noise.
All right. So, so the focus would be more towards the industry and how the robotics is being used in the industry. So, but before that, let me go back a little bit and set the focus right why we are talking about robotics today. So today is the time when we are migrating from third industrial revolution to the fourth industrial revolution. So it all started with actually the first industrial revolution when we talked about the steam engines, then we talked about the mass production, and the automation is when the controls and robotics or the hard automation were more prominent. And I think we all have seen the complete third industrial revolution, and we are in that phase when we are seeing the industry migrate from the third industrial revolution to fourth industrial revolution. So in short, we call it as Industry 4.0. So basically, what Industry 4.0 brings to the table is the combination of digitalization and digitization, which means the collaboration of the design and the controls and many other things over the web. So when I talk about the industrial revolution, digitalization, what essentially it brings for us, it gives us an integrated value chain, which means the flow of information between different departments, between different countries, zones is seamless. So it's not like each department or each organization is working in their own silo. The flow of information becomes seamless, thereby, actually, in short, what is the meaning of Industry 4.0? It's basically to have the seamless flow of information between different departments. So it's not like maintaining files and sending it through some person, or there is a lag of information. So all these errors or the problematic things are completely siphoned off when we are talking about the implementation of Industry 4.0. Apart from integrated value chain, we also incorporate the technology of product and production twins, which is nothing but the digital form of the product and the production and how that product will actually perform. So basically, we are talking about the digital twin of the product and production. So in the next slide, I will talk in detail about what do I mean by digital twin. And third is the cyber physical systems, wherein we are talking about the flexible and autonomous electromechanical things. So what does actually digital twin means? So I'll start with an example. So today, if I want to design a water bottle, let's say a simple water bottle, then that's the concept that I want to have one water bottle. So that's the idea. and I need to put that idea into some digital format. So it can be a CAD software. So I would like to put the idea or the image of that water bottle into the digital format using some CAD tool. So that's the digital twin of the product, which is in the form of ideation. Then the second part is the realization. Now, how this bottle would be made? What would be the process of manufacturing this bottle? So that complete production methodology I would like to put inside in the digital format. That's called the digital twin of the production setup. Then third is the utilization. How if what if the design which I have made is functional or not functional? Is it useful for the customer? So that's the concept of the digital twin of the, we call as the performance. So if I take the example of an automotive or a car, so the, how do we say that the car is good? It should have minimum NVH, noise, vibration, and all those things should be minimum. So that's the performance level which we check. So that we call it as the digital twin of the performance. So in other words, we are calling it as identifying them as digital twin of the product, digital twin of the production, and digital twin of the performance, which means we are not actually making the product. We are making the product digitally first. We are validating the production scenario digitally first. We are checking the performance of the vehicle or any object through digital performance first. So when all these digital twins are verified and completely validated, then we get a complete through this holistic digital twin, we get our matured product in the market. So that's the concept of the digital twin, and that's an integral part of Industry 4.0. So if I go back to my first slide, then Industry 4.0, it was written as digitalization. So we have converted everything from product, production, and the performance into digital format. And how are we exchanging the information? That is through digitization. So Industry 4.0 is nothing but the combination of digitalization and digitization. So these are, I'm on slide number 4. Please raise your hand if there's some lag, or if I must go slow, please let me know. So I'm on page number 4, which talks about the components of the digital factory. So these are the various components which make our factory digital or compliant to Industry 4.0. We should have the autonomous robots. We must use the big data, sensors, deep learning, AI, ML, Internet of Things, cyber security. So all these components are very important. But at the same time, you also see that robotics is in the thick of the things. So robotics plays a major part. Rather, the robotics have evolved over a period of time. So it's not only robotics, we will be talking about advanced robotics. So advanced robotics is nothing but integration of the advanced functionalities of the artificial intelligence and the combination of various sensors. So uh, now you look at this particular graph, the robot population worldwide is increasing ever. So at the rate of about between 20 and 30%. So if we go see till 2021, as per the information from this website of IFR, it shows that the average growth would be around 14%. So of course, this has not considered the current scenario of COVID, but we all can stay positive only. So positive is the way to go forward. So as per the data, the 14% is the average growth of the robot population worldwide. And if you look at where India stands, then India's robot population is also growing gradually and at a fast rate. So if we compare it from 2017, the robot population has increased by around 40%, which is a good increase. And it's not, and this population, robot population increase is not restricted to any specific industry. if we had, if I go back to 2013-14, then the majority of the robots was in the automotive sector. But in the last 4 to 5 years, the implementation of robotics plays a major role. But what is the use of robotics in the electrical and the electronics that we understand from the assembly point of view? So there are multiple robotic vendors such as KUKA, FANUC, ABB. All these robot vendors are making robots not only for the automotive organizations but for different organizations, or the general purpose robots, and which would cater to all the industries. But now we see now the supported, why we see this big trend of robot population increasing. There's a reason, because the manufacturing trends in the industry are such that it demands for the robotics. Because we are talking about, if I talk about an automotive organization, now any single organization, automotive organization, is not making single vehicle uh, on their line. So a single line is producing perhaps 4 to 5 different variants of the car. So that's called the flexible production, which means uh, if there are 4 robots on a single station, so that particular 4 robots or station is not working for one car. So they would be reprogrammed, or the programs will switch from number one to number two, looking at what type of car is in front of them. So that's the flexible production. The robotic programs change automatically whenever a different variant of the car comes in front of them. So global expansion is again a very important cog in the wheel because of Industry 4.0, because it means that we are designing at one place and we are building at another place. It's really not necessary that if I'm making the car in India, then it has to be designed in India. So if you're designing the car in India, you can produce that car in Europe as well. So that's the global expansion, which means the flow of information or the flow of data has to be seamless and without any kind of delay and errors. Shop floor complexity, when we are talking about flexible production, which means we are also talking about the shop floor complexity. There will be so many electromechanical equipments which are talking to each other. So when they're talking to each other, the controls part plays a major role. So it is not, we are not talking about one single PLCs. It can be a combination of multiple PLCs, and it can be a combination of multiple PLCs of various makes also. So that's the shop floor complexity that demands for the implementation of the new technologies. And strive for quality is, I think we do not want to launch a product in the market which is not good quality. So that's the reason new technology components have to be introduced. So constant improvement is like reusing the engineering knowledge. So if I have designed one car today, so when the turn comes for the next car, I should not be restarting the engineering from the step one. I should be able to reuse my previous engineering knowledge to the next project. So that's the jinx of what are the major manufacturing trends that leads to the implementation of robotics in a major way. So when we are talking about the implementation of robotics, it's not that we buy a robot and just put it. There's so many things which come into picture while implementation and the commissioning of the robots. The robots have to be placed at the right position. We have to think about the task distribution among the different robots, and at the same time, when the robots are working, we have to consider about the safety aspect also, and at the same time the controls point of view also. So there are many implications when we are talking about implementation of robotics, which means we need to have some kind of solution which can be a simulation technology which gives us a matured solution, or an optimized solution to us. So that simulation technology must I mean, must address all those manufacturing challenges and the implementation, and the implications of implementing the robotics. So I don't want to get into the details of the simulation technologies, why these simulation technologies are there, but what can we do using these simulation technologies when talking about the robotics. So this is one first example of a car organization where there are multiple robots working together to make one car. So it's a combination of various electromechanical equipments. There are robotic weld guns mounted on top of the robot. So the demand of the industry is that the operator or the shop floor person should not be spending too much time on the shop floor. So the simulation technology helps the engineer to validate all those things in the simulation software and program the robots of any make and validate them inside the simulation software so it can be downloaded directly to the shop floor. So there are multiple components when we are talking about the usage of the robotics in the simulation environment. We have the robot controller software, which we call as the RCS. Normally, this RCS is developed and given by each robot maker, and then there is the OLP, that is the offline programming concept, which helps the simulation software to download the robotic program in the right syntax as required by each robot vendor. So as I said, there are multiple robots which require to be programmed, and then this simulation tool should be able to provide a matured robotic program and we must be able to validate that program inside the simulation technology. So this tool, which is being developed by Siemens, has been used in most of the industries in India, and it's a generic tool for all the robots. And with the help of this tool, simulation tool, one can generate or add all the proper syntaxes of the robotic program. One can define the input, output, or any kind of signal that is required for the robot to communicate with the PLC or the robot controller itself. So any production line will not be making just one car at one time. So it can be a combination of various cars. So we call them as the variants. So we can check the production scenario of different variants inside the simulation software. At the same time, we are also doing the event-based simulation. When I say event-based simulation, that means if a robot is having a gripper in his hand and it has to pick the part from the fixture, then when should the robot move? The robot should move only when the clamps on the gripper are open and the part is present in the fixture. Only then the robot should move down. So that's the event-based simulation, which means when event A happens, only then event B will happen. And when event A plus B happens together, only then the event C happens. So that's the meaning of the event-based simulation. So in this simulation technology, we are checking the production behavior uh, of two variants or multiple variants being produced in the same environment, and what would be the different robotic programs that are also validated inside the simulation environment. So that is the pick and place application. So with this, we also or the industry also looks for the simulation solution for the arc welding. So this is a normal 6-axis articulated robot, and when it is working in synchronization with the trunnion, we call it as the 8-axis robot because it is also controlling the movement of the trunnion, which has 2 axes. So a 6-axis becomes this 8-axis robot, and it works in proper synchronization with the other 2 axes of the trunnion. So the task which normally is being done on the shop floor in 7 days or 8 days of time is shortened, I think, and can be completed within one day. So another one application of the robotics is the deburring application, wherein the robot is picking up the tool and doing the deburring application, and we are also monitoring the robot joint behavior in the robot viewer on the right hand side, which helps us in smoothing the robotic motion. So it's not only limited to just one robotic uh, uh, vendor. So any robotic vendor, it can be Kuka, Fanuc, Yashikawa. So all these robotic vendors can be put to test here. So this one example is of a dual-armed robot being used for assembly applications. So it is controlled by a single controller, but have two arms, which looks like more of a humanoid. And both the arms of the robot are properly synchronized, and more this kind of robot is mostly used for the assembly kind of applications. So in this case, you see that amplifier is getting assembled here, and we can easily plan the motions offline rather than doing them online on the shop floor. So this is the application of robotics and how robotics can be made easy with the help of simulation. So that was now up till this I have spoken about the usage of robotics, and whatever we have seen till today or till now are the traditional robotics, right? Now, what is the way forward? So, what is the way forward? Because whatever I've spoken is completely again independent of what other part of the factory or whatever is happening in the design house. So, the way forward is to have a flexible and autonomous kind of solution. So I think that's the motive for all of us to be in research and development and do more research towards making the flexible robots. Anyways, the robots are flexible, but the autonomous, where the human intervention is very less. So I think it all started with fixed manual, where there were no robots, then the flexible manual, then we have the fixed automated lines. Whatever we had seen in Industry 3.0, we have spoken about the fixed automation, fixed and automated. And now Industry 4.0, we are talking about flexible autonomous, which means the robots or any programmable devices which we are using should be flexible enough and should have minimum human interference, and the communication should be seamless. So that's the demand, and that's the way the industry is looking forward to, and it's completely a closed loop. And I think with the help of digitalization and digitization, we are going to make it a closed loop, so that if I design from point number one, then the feedback should also come to point number one, so that I could make the changes at point number one and send it to the shop floor for all the changes after receiving the feedback. So that is reflected in this graph, that the industry is also responding very strongly on adaptation of the advanced robotics. We can see the growth, which is growing at, I mean, drastic. I mean, that's 46% from the manufacturing point of view. And if we see in the logistics point of view, we could see again a very strong growth at 22%. So that shows that the usage of advanced robotics is increasing rapidly. So when I say advanced robotics, I mean to say the usage of sensors, AI, ML, cybersecurity, and all those components of the industry 4.0. So from Siemens terminology, I would say advanced robotics is a combination of various technologies, and the industry is responding very strongly. So so this video, you would see a very strong technological component, which we call as the virtual commissioning. Normally what happens, there's a production line wherein there are 100 robots or 50 robots, and uh, the PLC is always talking to the robots and the peripheral equipments. So normally the PLC programming is done in the design house, and the robotic programming is also done in design house. But the handshake between these two components is done on the shop floor. So that's the commissioning phase. That's the real commissioning phase. So I'm talking about the concept which is called the virtual commissioning, wherein the virtual setup of the factory is being run by the software model of the PLC. Now, in this video, you would see that I have an HMI which is running from the actual PLC controller and managing the production environment in my simulation tool. So which means I have done the proper mapping of the signals inside the simulation software with the schematic HMI. So what normally this helps? So this helps us in debugging the PLC program at the early stage and check all the what if scenarios at the early stage. So when I go to shop floor, I'm not doing any kind of debugging on the shop floor because I have done all that debugging or optimization in the design phase itself on my laptop directly. While when the robotic programs are now more mature now because I have validated where the signals have to be put and what kind of signals have to be put. So any kind of optimization is also done in the early stage itself. So the industries are now saving at least 30% of their setup time on the shop floor. So that is also an integral part of Industry 4.0 when different departments like the design, robotics, and controls are working hand to hand. So what essentially it does, earlier in the office, people were working on the layout, simulation, designs, and planning, but the controls and the handshaking part of the robotics was done on the shop floors. So what virtual commissioning has done has put that controls and programming part in the office setup only, which means the shop floor tasks are now shifted to the engineering level. So the robot and now the shop floor, the robotics part is now left to the shop floor, and the integration part is now left to the shop floor, and the handshaking time is reduced drastically. So what essentially it does, the mechanical guy is doing his own work and electrical guys is doing his own work, and both the guys now are working together hand in hand to have to evaluate their mechanical and automation system behavior. So slide number 22 talks about the concept on what virtual commissioning works. So we have this simulation software on the left hand side, which is connected to the PLC program or the HMI. So we are validating the complete production setup using the PLC code inside the simulation software. And once it is validated inside the simulation software, we just make the switch and connect the PLC, the real PLC, to the factory operation. So we are validating the complete operation of the production line without damaging or breaking anything. So it's completely safe from human and the safety point of view, and really easy from the equipment's point of view, because we are not testing our PLC program on the real product, but we are testing it on the virtual setup. Give me a second. So the next component is the smart assembly robotics, wherein we are seeing the usage of the cobots. So cobots are the robots which work hand in hand with the humans, which means they are smart enough that they do not harm the operator or the guy who is, or the engineer who is operating it. So it's very easy to program. One can just program this robot by holding and moving it uh, just by the hand and programming that and recording that particular location. So it is used in collaboration with a third party company which is called the RT Minds. So RT Minds helps to program this robot, and this program can be directly transferred to the simulation software, where a complete process can be validated. Because when we are programming the robot, we are just programming for, let's say, pick and place operation, but uh, it has also to perform multiple operations. So those multiple operations and checking of the collisions and the checking of the camera also can also be done inside the simulation software. So what we have on table is a complete matured program, or the complete setup, matured setup, which is completely validated. So AGV commissioning is the second, is the third very important component which will be introduced into the industry in a big way. AGVs, automated guided vehicles, where it's completely autonomous, and we are commissioning this AGVs with the help of virtual commissioning, which means the PLC coding and the PLC programming of the AGV is also validated in the simulation software directly. So AGVs are the ones which can carry the product, or which can carry the robot itself also. So with the help of various advanced simulation technologies, we can program the AGVs, we can validate the movement of the AGVs, we can plan the path of the AGVs, and we can also check its communication with the fleet management as well. So there are multiple fleet manager organizations in the country which talk to the PLC as well as the AGVs, and plan their paths accordingly. So this AGV can also be directly connected to the PLC program and checked for its behavior. Now you see here that the AGV has brought the component towards the robot, or in the other case, it could be that the AGV is bringing the robot towards the part. So it can be both ways. So you see, it's a proper ladder logic program which is being used to run the robotic setup, and we can anytime change this ladder logic and run the download the program once again and run it. Now again, a very important and interesting functionality of the industry 4.2 is the usage of the virtual reality, wherein we can make use of the HTC Vive headset which this guy is wearing, and he is standing, if you see on the right hand side, in an empty space, but while he is wearing this headset, he is connected to the simulation software environment and could see the actual production setup in an immersive manner. So with the help of this handheld device, the remote, he can jump anywhere or teleport anywhere onto the station, uh, anywhere in the station. Since these program robots are already programmed, he can run, play, and pause this simulation at any given point of time. While he is looking, observing this simulation, standing right in the middle of the production setup, he is not getting hurt. So that's the advantage of using the virtual reality. He can move the robots just by just by using the handheld device, and he can also jog the robot with the help of the handheld device using the TCP, the tool center point frame. So there are multiple benefits and functionalities of the VR also. You have this torch in the handheld device. This is not an actual torch, but again, this torch is virtual. But when you are wearing these glasses, you could see the actual light being put on the dark surfaces, and you would feel like that you have actual torch in your hand, and you can throw light at any place, any dark spot, and can visualize it. So that's the function of having this torch light. And while you're observing this inside the immersive environment, you can always give the technical feedback. You can make the technical feedbacks and give it to the design people who can make the changes. So that's the closed loop. So we have been talking about the closed loop of the digital functionality. So that's the closed loop. That now we are in the production setup. The line is working, but while I'm in the immersive environment, I could see many things which are not right. So I could make a note of them and send directly to the design engine. So the benefit again of virtual reality is that uh, two people at two different sites can visualize the same simulation at the same time. So we call it as the multi-site collaboration. If I have designed this simulation and I want to show it to someone in Jamshedpur, then we both can wear this HTC head vibe and can visualize this complete environment by immersing ourselves into the production setup. So, apart from the normal virtual reality, we can also validate our production environment using the HMI also, which means the virtual commissioning part is now also can also now be integrated with the virtual reality. So the HMI sizes and the widgets can be controlled at any given point of time, and you can run the production environment, the simulation environment using the HMI in front of you. So Siemens have been working a lot on these different high-end technologies, advanced technologies, and is the leader in the market actually. So when it comes to the digital transformations, so most of the organizations in the world are using our tool for simulations, and people have seen a lot of benefits. The time which they have been spending earlier, now they are spending a lot less of time when they use these simulations. So for robotics, simulation is very important. So I think today I've spoken only about the robotics from the manufacturing point of view. I'm sure your motive is more towards the research, but my idea of giving this presentation today was on the insights of the industry, what industry is looking at, and what is trending in the industry, and how Siemens is working towards, complementing the needs of the industry, and what all we should do. And if we are doing some work for the industry, then what could be our focus and what could be our direction. So that's my motive. So that's a complete factory. That's for the representation purpose. It's a complete flexible factory where we have multiple stations, multiple areas producing different parts, and we have incorporated number of technologies here. We have incorporated the use of AGVs here. The part is being fed using the AGVs, and there are AGVs which are used for logistic purposes. And these AGVs are smart enough to find out any collision in front of them and to find if there is any human in front of them, so they can stop or change the path. And the complete in this smart factory, we are seeing almost negligible human intervention. So parts are being loaded directly, accurately, and when the task is completed, the AGVs collect that part and move forward. So in front of us is the production of the batteries for the electric vehicles. So Tesla has been using our technology, and for this laser welding also. So the tools are smart enough now. The robots are also so smart enough to find out where the welding has to be done. So because there is always a difference when we simulate it and when we actually directly go to the shop floor. So there's always a difference in the parts and where it has to be welded. So with the help of smart tools, we do it. Now on in this snapshot, you would see that a cobot is handing over the part to the human operator, and when the parts are being loaded, the AGV moves to the next station. So that's called the autonomous and flexible kind of manufacturing, or the smart manufacturing. So I think I could complete this within 50 minutes of the time, and I'm open to any kind of questions from your side, and please let me know if there are any kind of questions. Are there any questions?
No, sir.
So how do we take it forward, Dr. Dalla? So can we close this session, or how do you want me to take it forward?
I think Vijay sir muted his mic.
Okay.
I think we need to wait for half minute.
Okay.
Sir, I have a query regarding, sir, Siemens India also working on robots which has been used in surgical robotics, sir. Is there any utilization or working project or something like this?
Actually, Siemens directly does not make any robot, but we provide the motors to all the robot manufacturers. So, from Siemens' point of view, we are not robot makers, but we assist the robot makers to make the robots. And when it comes to the simulation, then we can simulate any kind of application.
Okay, sir. Okay, thank you, sir.
I could see one question, some points related to clone. And can you please elaborate me what exactly you mean by clone here? I do not understand the meaning of clone here, because clone means replica or the copy. But in what context this question is, I'm not able to relate actually.
Yeah, Aman ji.
Ji.
I think we should close it. Yeah, Aman ji.
हाँ जी डॉक्टर डाला.
So I think one more. I think your colleague had also joined with you, na?
Sushil.
Yeah.
Sushil Jain.
Okay.
So I think Sushil is going to talk about AI and machine learning tomorrow.
Okay.
So I
Tomorrow.
think his session is, I think his session is scheduled at 10:30 or so. I'm not sure.
Yeah. So Aman Gargaji, once again, thank you for
Rather,
engaging this session and making it successful. And regarding addressing the theoretical knowledges, practical knowledges, if we get information about the recent development and the recent whatever the outcome. So obviously this makes this becomes the reason for the success of this type of activities. Ultimately, our purpose is to develop something for society. Our main purpose is ultimately to develop something for the society.
Correct.
So already you are doing this kind of activities you are doing. So once again, thank you. You covered a lot of things within 1 hour.
I think that was too much because I tried to compress everything into 1 hour, because if we take each subject, then we can spend, I think, lot much time on each subject. Like I talked about AGVs, the virtual commissioning, smart robotics. So each topic we can spend at least 2 hours. So
Yeah,
I tried to just give a glimpse of what are the new technology components being adopted in the industry.
yeah. Yeah, that's why I'm saying within the 1 hour you have covered a lot of things.
Yeah, I tried to. Yeah.
Yeah. Yeah. So thank you, Aman sir.
Thanks. Thanks a lot, sir. Thanks a lot. Thanks a lot for giving the time to us and showing what we know. And I mean, I'll be open for any kind of discussion further. I've shared my email ID as well, aman.garg@siemens.com. So if you think I can be of any help in future, please let me know.
Yeah, definitely. We require.
Thank you. Thanks a lot.
Yeah. Thank you.
Thanks a lot. Thanks a lot for attending the session. Thanks a lot. Thanks all.
Yeah. Thank you.
Good day.
So, dear participants, regarding updates, PPTs, and tomorrow's link, the online test link, I will be sharing through the mail. So just after you can say within the half an hour, I will be sharing it. So thank you. Thank you.
Okay, sir. Right. Thank you.
Yes, sir.
Thank you, sir. Vijay, sir. Thank you.
Yeah, whatever the updates. Yeah, sir. One request here. We want
Yes.
PPTs. Actually, our participants are asking for PPT.
Yes, sir. Yes, sir.
Okay.
First day you are given 5 or 6 PPT,
Okay.
but
Okay.
it is asking us to get a permission. But after that, you are sent only 2 or 3 that you are able to download. The first mail what you have sent 6 or 7 that we are unable to.
No. That's why later I sent the same mail. So
Okay.
that is accessible to all.
So accessible only one PPT and 2 yoga.
No. All PPTs are accessible now. Three times I have sent. So ignore the first one, the second one, and please follow the third one regarding the
Okay.
PPT.
Okay. The first one you are given 5 or 6 attachment. Now it is possible to download.
Yeah. If you see
Yes,
now,
yes,
if you see,
yes.
you just type you just search my email ID, then you will find
Okay,
it.
okay,
Okay.
okay, sir.
Okay.
Okay,
Thank you, sir.
okay. Thank you, sir.
Yeah.